Very good evening, all of you guys. Welcome to Unacademy. Welcome to the session. So, how are you all? So, kindly respond. My audio, video, everything is fine or not? I hope everything is fine. Good evening, Janil. Very good evening. So, we'll start slowly so that the people will join over a period of time, like yesterday. Good evening, Divya. Very good evening. Once again, very good evening. I'm just waiting for you people to join so that your friends join, then we can start the session happily. Okay, then let's start. Hi, Sahil. Hello. Right. So welcome to an academy. Welcome to the my session, guys. आप लोग तो कल क्लास में अटेंड किया. We have discussed very good concepts on the marathon sessions. That is the basics of the network analysis. हमने क्या क्या डिस्कस किया बेसिक जस्ट क्लासिफिकेशन ऑफ द एलिमेंट सोर्सेस इसके बारे में डिस्कस किया इसके बाद वी हैव डन with the KCL, KVL, node, mesh analysis. We have not discussed mesh analysis. We did up to node analysis and we have discussed a few problems on node analysis also. And after the problems, we have done uh, up to basic level node analysis questions. We still left over with some things like what we call yeah, super node, super mesh, all those kind of questions we have not yet done. Okay, so today we'll be doing that and we'll be doing discussing some questions on equivalent circuits, series connection, parallel connection. This is my plan. So depending on the strength, I may take one more session so that you'll get some kind of conclusion of the basics in these three sessions. So today maybe I'll take for 1 hour only, or I may extend also. So it depends on the continuation of the topics and the response. We will decide. But today minimum I'll be taking 1 hour. Okay. Chalo. Actually, I have some work today, but I don't want to miss the continuity. That's why at least 1 hour to le sakte. So that is the reason like I thought of taking on Monday, but let's see if possible. I'll take for more time. Nahi hai to today I'll take for 1 hour and Monday I'll be taking one more session for you. Okay. So let's go. Chalo. Good evening, Prashant, Ravi, everyone. Very good evening. Okay. Chalo. Let's move. So this is about me. This is Bhima Sankar. I did my Mtech from IIT Kharagpur. I have 12 years of teaching experience in GATE and ESE throughout the, sorry, 11 years of teaching experience in GATE and ESE throughout the country. I'm expertise with the subjects of network analysis, digital circuits. In the last 10 years, I taught to several thousands of students like you people throughout the country. Basically, to give the inputs to the students who don't have any knowledge about the subject, I always enjoy teaching to the students who don't know anything. After attending my class, they feel that yes, we learned something. We never think we can learn in this way. These things makes me more and more happy. I'll always try to give you that. Okay, so coming to an Academy Plus subscription, आप an Academy Plus subscription लेना चाहिए तो You can don't delay it further guys because you don't have much amount of time. So इसमें आपको बहुत सारे benefits है. आपको मिलेगा top educator का classes plus classes you will be getting both live and recorded. You can watch your convenient time. कोई भी समय पे देख सकते हैं, कितना बार चाहे तो उतना बार देख सकते हैं. You can watch any number of times without any restrictions. We have multiple batches, comprehensive, crash, and many different type of batches. Okay, and yeah, in these batches you can watch the comprehensive course. Then you have a choice of educators also on the Plus platform. After the comprehensive course, you will be getting the classes of what we call we can say you can get the rank improvement, crash batch, test series is also available right now, and you will be getting the notes which you can watch, I mean which you can access anytime anywhere. हर 3 सेशन के बाद एक डेडिकेटेड डाउट सेशन भी आपको मिलेगा. सो इसके अलावा आपको पर्सनलाइज्ड कोचिंग चाहिए तो पर्सनलाइज्ड कोच चाहिए तो आप आइकॉनिक सब्सक्रिप्शन ले सकते हैं. इसमें आपको बहुत सारे बेनिफिट्स है. 1-to-1 मेंटरशिप मिलेगा, पर्सनलाइज्ड गाइडेंस यू विल बी गेटिंग, एंड यू विल बी गेटिंग पीरियोडिकली strategy sessions, motivation sessions, or you will be getting some sort of timetable and guidance who will drive you to reach your destination in the best way. And also physical notes is going to get. This is what you will be getting with the iconic subscription. Okay, right. So this is my code. You can use Shankar10. You will be getting 10% discount on any subscription of Unacademy, whether it is Plus or Iconic. You can see these are the prices, and इस पे आपको 10% discount मिलेगा by using the code Shankar10. If you love my teaching, if you like to join Unacademy, you or your friend, anybody, while joining, you can always use my code Shankar10. चलो, right, कल क्लास थोड़ा सा रिवाइज कर रहा हूँ. This is what we can say the syllabus of network analysis, and you can see this is the classification of elements. Okay, this is the classification of elements which we have discussed yesterday. I haven't discussed anything, I just gave the outline here. And also independent, dependent, ideal, practical, voltage sources. आपको पूरा कंटेंट चाहिए तो लक्ष्य क्रिएट्रिक्स चैनल पे प्लेलिस्ट पे जाओ. लक्ष्य बैच में network analysis, already my full course is available for you. In Tesla batch, this network is already available in English and Hindi, right? So KCL, KVL के बारे में हमने डिस्कस किया, and we have discussed the basics like simple node, principal node, and the definition of the KCL. In a lumped electric circuit, any point of it, any node at any point of time, the algebraic sum of the currents leaving the node equal to 0. हमने examples दिया pipeline वाला, and yes, the currents entering is equal to current leaving, charge entering equal to charge leaving. इसके बाद KVL के बारे में डिस्कस किया. आज मैं नोट्स भी देता हूँ क्रिएट्रिक्स टेलीग्राम चैनल पे. आज नहीं है तो कल तक मैं देता हूँ. ओके, ओम्स लॉ के बारे में, व्हेन इट इज एप्लीकेबल, व्हेन इट इज नॉट एप्लीकेबल, इसके बारे में भी डिस्कस किया. नोड एनालिसिस, वी टेक वन एग्जांपल एंड आई हैव एक्सप्लेन्ड इन ए क्लियर पॉसिबल वे. राइट, नाउ लेट्स गो फॉर मेश एनालिसिस. Thank you very much, Srujanasri. Thank you. Right. So before going to mesh analysis, I want to give you some disclaimers. Can you tell me where can I apply mesh analysis? Yes, lumped electric circuits में mesh analysis is applicable. You know the difference between mesh and loop. Yesterday we discussed. Mesh में क्या होता है sir? It should not contain any other loop in it, but loop can contain another loop inside it, right? Any closed path is a loop. So every mesh is a loop. Every loop is not a mesh. These things we discussed yesterday already. So importance of mesh analysis, why not loop analysis, why mesh analysis is, it will avoid the unnecessary number of equations. आप कुछ प्रॉब्लम को 2 इक्वेशंस लेके सॉल्व कर सकते हैं, इस समय पे 3 नहीं लेना चाहिए. ओके, हम कम से कम इक्वेशन से प्रॉब्लम सॉल्व करना चाहिए. रिडंडेंसी को अवॉइड करने के लिए हम मेश का कॉन्सेप्ट इंट्रोड्यूस करेगा. बट KVL is basically applicable for loop. Any loop में KVL always applicable. Okay. While performing the mesh analysis, other than yes, it is true lumped electric circuits में तो applicable है. इसके अलावा आप बताओ, is there any other, I mean, any other place where we can apply this mesh analysis? I mean, sorry, not any other place where we can apply this mesh analysis. Where which kind of networks we can apply the mesh analysis? Which kind of networks we cannot apply this mesh analysis? आपके माइंड पे कुछ पॉइंट है तो बताओ, नहीं है तो I will be explaining. Please comment. Thank you, Surya. Hi. So guys, please comment. ठीक है, बताओ यार. नेटवर्क, अरे भाई बेसिक्स अभी शुरू किया, आप लोग तो नेटवर्क थ्योरम्स टैंजेंट के बारे में आप कमेंट कर रहे हैं. थोड़ा सा वेट करो, हर महीने एक दो टॉपिक्स में लाके मार्तन सेशंस करता हूँ. डोंट वरी अबाउट इट. सो प्लीज फर्स्ट लर्न द बेसिक्स प्रॉपर्ली. ओके, पूरा टॉपिक्स तो ऑलरेडी हमारा प्लेलिस्ट में रिकॉर्डेड पे है ना भाई. चलो, नॉट अप्लीकेबल फॉर नॉन लीनियर. ओके okay, you are saying only for RLC network theorems में not applicable, you are saying Pratik. Okay, fine. Any other? I will explain you. I will be explaining you guys. Listen carefully. Here, the mesh analysis will be applicable for planar networks only. So let me write that point. Mesh analysis is applicable only for planar networks. ठीक है भाई. प्लानर नेटवर्क का मतलब क्या? प्लानर नेटवर्क का मतलब क्या? In a two-dimensional plane, if we are able to draw the network without any crossing, then it is called planar. आप नेटवर्क ड्रॉ करने समय पे कोई भी टू डायमेंशनल प्लेन पे विदाउट एनी क्रॉस अपॉन ईच अदर, इफ यू आर एबल आर कैपेबल टू ड्रॉ द नेटवर्क, इन नेटवर्क्स को बोलते प्लानर नेटवर्क्स. नहीं है तो नॉन प्लानर. आपका मैश एनालिसिस जो है ना, इट इज एप्लीकेबल ओनली फॉर प्लानर नेटवर्क्स. ठीक है, लेट्स मूव फर्दर. For example, you take this example. These are the resistors. It's a clear planar network. Okay, fine. So let me take one more example. In this case, what happens? This is the first one. Second one. This is the network. This is here. There is a crossing, but इस case में भी it is also a planar network, क्योंकि we can keep or draw this outside the network. We can draw this outside the network. Okay, so listen here. Okay, outside the network we will be drawing this. Understand? In this case both are same na, so here no crossings na. This is again planar. No problem. Let me give you one more example. It is a planar or non-planar because you have this junction. Junction is nothing but a node. It is no problem. It's a planar. Last case. इस केस में क्या होता है सर? You draw this network in any way. ये वायर इस साइड पे ड्रा करो, ये वायर इस साइड पे ड्रा करो. You cannot remove this crossing and draw it. But previous case में क्या हुआ सर? You can remove this crossing just by drawing it outside. But इस केस में ये वाला जो क्रॉस है ना, क्रॉस का मतलब ऐसा, not ऐसा. ठीक है, like this. इस केस में you cannot draw it outside this network. These kind of networks में mesh analysis is not applicable. This is what we call non-planar network. Got it? Everybody here understand? Right. So now mesh analysis is applicable for only planar but not for the non-planar networks. Thank you, Ujjwal. Right. Right. कॉस्मोस नॉन प्लानर और प्लानर पे केसीएल केवीएल हमेशा अप्लीकेबल, केवल और केवल मेश एनालिसिस इज नॉट अप्लीकेबल. अंडरस्टैंड? ओके, थैंक यू. सो नाउ लेट्स मूव फर्दर. चलो, let's take one example for your understanding. एक सिंपल सी एग्जांपल ले रहा हूं मैंने. राइट, सपोज दिस इज माय फिगर. इस फिगर पे मैं मेश एनालिसिस अप्लाई करना चाहिए. सो व्हाट्स द प्रोसेस टू अप्लाई द मेश एनालिसिस हियर? See, the first step when you apply the mesh analysis is identify the number of meshes. So please listen carefully. How many meshes are there here? So here, can you comment how many meshes are there here? How many mesh are available in this network? How many mesh are available? Very good. Two is right answer. This is one mesh and this is two mesh. Combinedly, it is called loop. Loops तो तीन है, but meshes are two. Mesh will avoid the redundancy, unnecessary taking of the number of equations. Second point तो ये है, assign the currents in clockwise direction. There is no rule you should take only clock. It is just a convention. Third point, like node analysis में हमने किया KCL और Ohm's law. Mesh analysis पे KVL और ओम्स लॉ. ओके, केवीएल और ओम्स लॉ करना चाहिए. इसके पहले प्लीज असाइन पोलैरिटीज अकॉर्डिंग टू योर अज्यूम्ड करंट डायरेक्शन. कैसा करना चाहिए सर? ये मेरा करंट है तो करंट यहीं पे एंटर करते, यहीं पे लीविंग, यहीं पे एंटर, यहीं पे लीविंग. करंट यहीं पे एंटरिंग, लीविंग, एंटरिंग एंड लीविंग. Okay, so listen, this is the current direction. I give the plus and minus like this. Suppose you are writing the equation at mesh 2. Mesh 2 पे equation लिखने समय पे what is you are going in this direction. Assume this is your loop equation direction. Okay, so here this is VR2, VC, VL. Okay, एक simple सी बात. To avoid confusion, use this statement. Assume I2 is greater than any. Okay, fine, right. Still, listen here. KVL क्या? What's your KVL? Positive to negative minus VR2, positive to negative minus VC, positive to negative minus VL equal to 0. I have applied KVL. Now tell me Ohm's law. Ohm's law क्या होता है sir? Voltage across the resistor is current into resistance. Next, capacitor का voltage formula 1 by C integral minus infinite to t current I2 dt. Again minus. अभी जान से सुनो भाई, जान से सुनो. Please listen carefully. In this element, two currents are flowing here. In this element, two currents are flowing. One is in this direction, one is in opposite direction. Two currents are flowing in opposite. The net result will be the difference between them. दो करंट्स ऑपोजिट डायरेक्शन में जा रहे हैं, सो द नेट रिजल्ट क्या होता है भाई? इट इज द डिफरेंस ऑफ द बोथ. सो डिफरेंस ऑफ बोथ क्या होता है सर? I2 minus I1 or I1 minus I2, please comment. Minus L into d by dt of, tell me, I2 minus I1. This is how you write the loop equations, mesh equations by using KVL and Ohm's law. Without writing two individually, you can also write a single equation. Let me write at the mesh one. ठीक है, mesh one पे I want to write the equation. See here, directly, no loop, no KVL, Ohm's law, directly single step. Assume I1 is more than any. Negative to positive V of t. Positive to negative minus I1 R1. Positive to negative minus L into d by dt of. अभी क्या होता है सर? इस डायरेक्शन पे हम इक्वेशन लिख रहे हैं ना सर. I1, when you are in this loop, you should write I1 minus I2. Directly, this is how you write the equation of KVL and Ohm's law together. That's the process. Simply what we can say as mesh analysis. So let's see the problems now. Are you ready? Are you ready for the problems? Yes, you can see Shiva. KVL के लिए कुछ भी restrictions नहीं. Start at the point, end at the same point. Total loop को भी you can apply the KVL. Okay. Mesh analysis समय पे number of equations ज़्यादा नहीं होना चाहिए. Redundancy. Suppose you take this loop, you covered these elements. इस loop में ये elements cover हुआ. But if you take this totally, there is no new element. That is the reason we avoid it in the mesh. ऑलरेडी ये सारे एलिमेंट्स लूप वन लूप टू तो कवर किया, इसलिए देयर इज नो नीड ऑफ टेकिंग द टोटल इन द mesh analysis. That is the reason. Otherwise you can happily apply for the external total loop also, all this analysis, no problem. Okay, चलो ready, very good. Just a moment. Okay, one moment. Okay, see here. For you questions. कल क्लास में मैंने होमवर्क दिया. Let's solve the problems, guys. Okay, so how many of you are able to solve this question? Let me check. Okay, so we'll do now over a period of time mesh analysis का problems, node का सभी का problems करते हैं अभी. Now please tell me what is the answer for this question. मैं तो ऑलरेडी आप लोगों को कल क्लास में होमवर्क दिया. लेट मी गिव यू वन मोर मिनट टाइम. टाइमर जी आओ. ठीक है, शुरू. गिव ए ट्राई. ऊपर से क्वेश्चन नहीं दिख रहा है. अरे यार, सॉरी यार. क्या करना. इस क्वेश्चन का स्टेटमेंट तो ये है, विच ऑफ द फॉलोइंग इक्वेशंस आर करेक्ट. अभी सही है ना. टाइम हो गया. It's everything fine. Now proper. Yeah, what's the answer? Tell me यार. मैं आपका आंसर के लिए वेट कर रहा हूँ. Option B, Divya and Cosmos. Let's see what is the right answer. So let me solve it. Okay. Here, firstly, examiner L dA1 by dt and L dA2 by dt. Uh-huh. Mm. Okay, let me write for the L dA1 by dt. L dA1 by dt is nothing but. Okay. Chalo. What is EC of t in this question? आपका EC equal to, this is the I2, right? Right. L2 d I2 by dt plus I2 into R2. Just KVL, loop equation only. Current enters from positive, leaves from negative. If you write this loop equation, VL2 and VR, what is the loop equation? Negative to positive, EC minus VL2 minus VR equal to 0. So, what is your EC? VL2 plus VR, where EC is equal to, what is this? EC is equal to, okay, VL2. What is VL2? L into di2 by dt plus I2 into R, Ohm's law. So this is one equation. So send this other side. What is your L2 di2 by dt? EC of t minus I2 R2. So minus I2 R2 plus EC of t, right answer. Okay. So this is third option is right. So one only galat. Okay, 1 to 4 galat. So your answer must be 2 3 4 or 1 3 4. So all you need to check verify is char will be 100% correct. No need to worry about it. I will prove it चाहिए तो. But whether 1 and 2 में कौन सा सही है, LDA1 DT क्या होता है, अब निकालना चाहिए. Same concept of loop equation apply करो. Current, let me take this, current is this direction पे है ना, VR1 and VL1. इस पे loop equation apply करो. ठीक है, आप ही बताओ यार. KVL in the first loop, negative to positive, E of t. positive to negative, minus VR1 minus VL1 minus EC equal to 0. अभी VL1 कितना होता है सर? E of t minus VR1. What is VR1? I1 of t into R1 plus EC. Sorry, minus EC. What is VL1? L1 di1 by dt. So E of t minus EC plus E of t minus EC and minus I1 into R1. So second equation is correct. First one to galat hai, minus nahi diya examiner. So 2, 3, 4 are the right answer. 4 भी हम प्रूव कर सकते भाई. ये I1 ये I2 इसको IC ले लो. आपका KCL क्या होता है? थोड़ा सा स्पेस कम है. प्लीज अंडरस्टैंड दैट entering current is I1, leaving current to I2 plus IC equal to 0. But what is IC? I2 minus I1. IC का equation क्या? C dic by dt, dvc by dt equal to I2 minus I1 आ रहा है मेरे को. I1 is entering, okay. I2 is leaving. So उस साइड पे ले यार. हम IC इस साइड इस तरफ ले रहा हूँ ना. So 4 is also correct. That's all. Question looks complex. Just if you understand the mesh analysis concept, very easily you can solve it. Anybody have any single minute doubt also, don't hesitate. Please feel free to ask me. I am happy to help you. So let me read your comments. If you don't have any doubt, please comment it is clear. I'll move to the next question. Right? What is E? E is the input here. This is your E. Okay, Pratik? Chalo, let's go for next. Nothing happened. You can write a single loop equation in that case. F war. Okay. Yes, it is the voltage only, Pratik. Okay, next question पर जाएगा. चलो. So this is the question we need to solve here. This concept is what we call supernode. Okay, right. So firstly, you people want to try. I can give you some time, and then I will be explaining that. Right. Please go through it. अरे यार टाइम हो रहा है 10 सेकंड ही बाकी है भाई. वेरी गुड. दिव्या तो दिया ऑप्शन डी. ओनली वन आंसर. ओके. See here, when there is a voltage source between two nodes, how to deal? Okay. So here, generally the way we write the equation is, I'll show you the method. When there is an ideal voltage source between two nodes, because the current in this voltage source cannot be found by Ohm's law. Okay, this condition is what we call supernode. This case may generally what we do is we join both of them and we write the equation combinedly for both of them. Neglect this resistor, it is of no use because it is parallel with the voltage source. Okay, right. So what is the current entering the node? -4. Then V1 by 2. Don't touch this part. Come here. V2 by 4 and plus 10 equal to 0. Right. So V1 by 2 plus V2 by 4 equal to how much? -4. This will give you -6. So V1 by 2 plus V2 by 4 equal to -6. Option A is the right answer. Generally, this is how you write the supernode equation for both the nodes 1 and 2. We should write the equation combinedly. Inside supernode, we must always apply KVL. इस loop में we should apply KVL. If you apply KVL, V1 plus 10 minus V2 equal to 0. V1 minus V2 equal to -10 is the second equation. ये दोनों सॉल्व किया तो आपको V1 V2 मिलेगा. Wait, listen carefully. ध्यान से सुनो भाई. Here I want to say one thing. Uh, I blindly write this equation. Okay, fine, you understand. Okay, how to write the equation is don't touch this part. Here you write the equation. Here you write the equation. Simple सी बात है. But there is this is true. Fine. If suppose you may have the doubt, sir, why I should apply this? What is the back end behind this? How you applied this? I can prove. I'll ask you one question. Suppose there is a resistor here in series, some 1 ohm. So this first part, is this valid in this circuit or not? Please comment. I have a 1 ohm resistor connected in series with the 10 volt source. Now this equation is valid or invalid? Please tell me. First equation only I am asking. Ministry of Railways. Okay. Most of the questions I discuss are PYQs of GATE ESE, but I select particularly where the question has something to teach. Okay, I mean, this question if I teach, students will learn this concept. जैसा questions I pick, hand pick करते, बहुत sources, कोई भी best source for preparation always any PYQs. Okay, but the way I pick will be different. Not valid, it's still valid. Yeah, it's still valid. Okay, so many people don't know these things. Simply they think supernode आएंगे तो हम ये concept apply करना नहीं है तो we cannot apply this concept. They will think like that. Okay, I will be explaining you how this equation comes, why I don't worry about this 20 ohm resistor, everything. Please listen, clear picture I'm going to give. चलो, listen carefully. Next page पे ले रहा हूँ मैंने. या ये वाला क्वेश्चन तो दिया एग्जामिनर V1 और V2 के लिए. Here this current is 4 ampere. Understand? This current is V1 by 2. This current is IR and this current is I. Understand? Here V2 by 4 and this is 10. So can you tell me what is the KCL here? Firstly, tell me here KCL at the second node. Entering current is I, entering current is IR, so I am taking minus in the I equation, and this is V2 by 4 and this is 10. Can I say I plus IR equal to V2 by 4 plus 10? Keep this point in your hand. ओके अभी ध्यान से सुनो भाई, इस वाला नोड पे क्या होते हैं भाई, -4 इज एंटरिंग, V1 by 2 plus I plus IR equal to 0. -4 V1 by 2 plus I plus IR equal to 0. So what is I plus IR? आपको ही पता है ना, -4 V1 by 2 I plus IR जो है ना, इसके अलावा हम V2 by 4 plus 10 लिख सकते हैं ना। हाँ, हो गया प्रॉब्लम। That's all. ठीक है। So here the concept of supernode is very simple, my dear friends. When there is a voltage source here, this is an unknown quantity. To avoid this, हम क्या करेगा? KCL चाचा क्या बोला हमने? The current entering the node is equal to current leaving. So this leaving का जगह पे ये leaving भी ले सकते हैं। बीच में originally voltage source और current source, resistor कुछ भी है सकते भी. You can apply this concept, but it is required only when you have a voltage source, that is ideal source, because this case may it is difficult to solve directly. Normal cases also you can apply this technique, nothing wrong, but we don't apply it because there it is not needed. ठीक है, जो enter हो रहा है ना यहीं पे, that is always equal to leaving, but this leaving is equal to this part, so instead of this I am writing this. That is the simple concept behind your supernode analysis. Okay, I hope this point is very clear for you guys. Please respond if you have still any doubt. You can feel free to ask me. अरे एक बुक नहीं है भाई, माय डियर MOS MOR, बहुत सारे बुक्स। ओके, सिंगल बुक का सोर्स में मैं डायरेक्टली क्वेश्चंस लाके नहीं करता हूँ। ओके, इट्स नॉट वन बुक। राइट, नाउ यू अंडरस्टैंड, वेरी गुड। Sachin Surya, is this clear? Sachin Surya. Sachin Surya. Hi Jeetlal, after a long time I'm seeing you in my class. Very good. Okay, let's move. Okay, yesterday class I asked you this question, so it's not visible, don't worry about it. आप लोग क्या करना चाहिए, I1 I2 निकालना चाहिए. Please try this. Please find I1 and I2. Earlier I told here, when there is a voltage source between two nodes, it is a concept of supernode. Similarly, when you are writing the mesh equations between two meshes, if between two meshes, if you get a current source between two nodes, voltage source comes, it is a supernode. Between two meshes, if current source comes, it is called as super mesh condition. Because here two important points generally we will be discussing in the regular class, the basics में, voltage source का current is a unknown quantity, current source का voltage is a unknown quantity. Whenever they comes in our network, if you need to find the current in the voltage source or voltage across the current source, उस case में we should avoid it or do by some alternative method. Okay, Here if you write the loop equation in this direction, क्या दिक्कत मिलते हैं आपको? You need to write the voltage across it, which is impossible because you cannot find the voltage of the current source. It depends on the remaining network. Okay, so this is the condition of super mesh example. So आप लोग ट्राई करना चाहिए तो ट्राई करके I1 I2 का आंसर्स आप लोग कमेंट कर सकते हैं. 5 -5 -5 5 15 -15 और -15 एंड 15 तो ऑप्शंस में दिया. हमें तो 1 मिनट टाइम दे सकते हैं आपको, एक नहीं तो 2 मिनट ले लो. राइट, टेल मी. Pradhan, whatever enters, yesterday class I already told you, कोई भी branch में whatever it is leaving should enter back. That is nothing but your return. इतना suppose you say this I1. Law of conservation of charge say this is leaving here. Will come back the same value or not? That is your return part. If I open circuit this wire, this current cannot go here. Then it will become 0. Time up. ऑप्शन डी. अरे कॉस्मोस, आपको ऑप्शन भी दिख रहा है, वेरी गुड. चलो गाइस, हियर दिस इज अ सुपर मेश कॉन्सेप्ट. ऐड दीज टू, like earlier I added two nodes now. Here you should add two loops and make a single equation according to this current direction. Okay, got it. Now first total loop का equation लिखो. KVL at, actually these two are meshes but we are writing the equation combinedly. Negative to positive 30, positive to negative minus I1 into what is the resistance value 1. Don't touch this person, यही पे आओ. Positive to negative I2 into 1, positive to negative I2 into 6, positive to negative I2 into 2. ठीक है, positive to negative I1 into 2 equal to 0. So 30 equal to आपको कितना आएगा? 3I1 plus 1 to 6 plus 1 7, 7 plus 2 9I2. It's first equation. Previously inside the node, inside the super node we apply KVL. अरे यार क्या हुआ? He applied the KVL na, same way here at this node apply KCL. What is the leaving current? I1. What is the entering current? I2. So आपका KCL क्या? Entry 10 is leaving, I1 is leaving, I2 is entering. So I1 minus I2 equal to minus 10. First equation, second equation. Solve 1 comma 2. Right? If you solve 1 comma 2, then you will be getting the answer I1 minus I2 equal to minus 10. Option A. Got it? 3I1. Okay, 3I1s is 15, 9 5s 45, minus 15 plus 45 30. Perfect. Option A is the right answer. Okay. So many people gave option A. Very good, yeah. Who is that? Divya, Saurya, and guess. Good. Remaining people, it's a good try. Whether it is right or wrong doesn't matter. चलो, let's move for the next. कल क्लास में ये भी मैंने होमवर्क दिया. How many of you are able to do it? I think something is missing in this question here. When r is 0 is 0. Okay. When r is 0, maybe v1 is 0. In that case, what is the v2? V2 will also be 0 in that case because it is short circuit. Maybe it is printed two times. This is the correct. Give a try. And then, very good. Cosmos to 40 diyas, Sachin. How much yesterday you might have done at homework? Option C. Okay. Okay. Firstly, V1 is 40, R is 10. When R is 10, V1 is 40. It doesn't have any meaning in this question. Why, sir? Because whatever may be V1, firstly listen. इस पार्ट को हम source transformation apply कर सकते हैं. Okay. So 60 in series with the 10, we might have not discussed source transformation, but if you have the basic, it's a very simple question of 6 parallel with 10, parallel with 20. Then this will be equal to 10 parallel with 20 is 20 by 3. Okay, 6 into 20 by 3, 40. So this is the condition, right? And this is your R. V2 side, this part can be replaced by a 20 and 520 is kitna 100 and 10. Okay, and here is your V2 and this is how much, again 20, right? So here 20, this is 30 na, 100 by 30, 10 by 3, parallel with 30. 20 parallel with 30 is 2, 3 is 6. Okay, 12. Am I correct? 2, 3 is 6 by 50. This is the source transformation. If you multiply them, it will be equal to 10 by 3 and this will be 440. So ultimately what I want to say here is this part jo hai na, you can replace this with a 40 volts and 10 by 3. Okay, and that is 20 by 3 आ रहा है. That is impossible. Just a moment here. मैं कुछ calculation गलत किया तो 10, 20. Why I'm doing just a minute. पूरा क्वेश्चन गया यार. Somehow we got our question back. Just one moment. I'll do by another method, which is Alok. I don't know यार. मैं तो नहीं देखा. Okay, I'm sorry for the delay. Okay, let me solve in a easiest way. Okay, when r equal to 10, right? He said this is 40. By KVL, if it is 60 and 40, what is this value? This must be 20. Accepted? Yes or no? Okay, right. Then what is 40 by 20? 2 amperes. What is 20 by 10? 2 amperes. KCL चाचा को बुलाओ. 2 आ रहा है here. 2 is going here. So current in this must be compulsory 0. Current in this must be compulsory 0. And current here 0. This voltage must be compulsory equal to this voltage. Right? Understand? So here 40 है तो here भी 40 ही होना चाहिए. Why I am explaining all these things means because when R equal to 10, this node voltage same. Even you vary this R also, it doesn't make any effect because the node voltage here and the node voltage here are same. Between you connect any resistor, it will not draw any current. Okay, the node voltage here and here are same. You connect any resistor, it will not draw any any current, provided this data is correct. But I feel that something wrong with the data. uh, okay, ये data सही है तो 40 is the answer. I'm not sure this data is correct or not. Okay, even because the node voltage here and here are same, the current is zero, irrespective of the value of the resistance. But I doubt that there might be something wrong with the data. Okay, yes, maybe because the camera calculation to nights are not satisfying. But this concept I applied, if it is 40 and this will be 20, there will not be any current here, then this is also 40. If both are 40s, your R value, anything also, still, always, what? Because this current is 0, na? This should give you here also 40. Let me check firstly it is giving 40 or not by current division which I have discussed. Still, I want to apply. I equal to 5 into 20 by 20 plus 30. That is 2. It is correct here. It is giving 2 means 40 is correct. Fine. Okay. Listen carefully. Here the question is find VAB. This is your VA, VB. Please calculate and tell me the answer. Calculate VA and VB and tell me the answer. Comment here, what is the voltage relation between VA and VB? Perfectly correct, Cosmos. 7.4 is the right answer. So these questions we should be little tricky, guys. You should not take, when you take the ground, you should confine the ground should be same in both the nodes, both the voltages. So let me take here the ground as the assumption like this. Here also ground is my assumption like this. Okay. So for example, some current I is coming like this. The same current I will flow here. The same current I will flow. What is this current? I1. What is this current? I1. So I1 coming like this, coming like this, coming like this. I1 will come. So I1 is the same in this all network. So is node pay leaving current is the same as entering current. So what is this current? 0. Got it? Similarly, if you take this current as I2, for example, this is my I2, the same will come here, same will come here, the same will come here. So I2 is leaving, I2 is entering. What is this current? 0. Okay, fine. Why I did all these things? Because I want to say that these all elements may current same, they are in series. What is your I1 is 4 upon 3 plus 6 plus 1. 0.4. What is I2? It is 8 by 6 plus 5 plus 5. 0.5. So here a 0.5 will give you a drop of 3. Here 0.4 will give me a drop of 2.4. Arrow direction should not miss. Okay, current direction positive to negative. So इस वाला लूप में आपने KVL अप्लाई करो. So what is the KVL? VA negative to positive plus 2.4, negative to positive plus 8, positive to negative minus 3, positive to negative minus VB equal to 0. VA minus VB is equal to how much? Minus 10.4 plus 3. It is minus 7.4. Very good, Sachin. Okay. Sachin तो सही आंसर दिया minus 7.4. Okay. Anybody have any questions in this? Any doubts? आप ऐसा भी कर सकते हैं, ये एक मेथड है ना, दूसरा मेथड में दिखाता हूँ इस क्वेश्चन को। ओके, लिसन, दिस इज वी ए, दिस इज वी बी। आप इसको ग्राउंड ले लो, कोई दिक्कत ही नहीं है, आपको जो फील कर रहा है उस पे ले लो। सो हियर 0.4 करंट आ रहा है, 0.4, एंड दिस विल बी 0.4 to 0.4. Okay, here 0.5 आ रहा है, already we calculated that 3. Okay, so what is VA between ground and VA? What is the voltage? Minus 2.4. Between VB and ground, what is the voltage? Negative to positive. So this minus 3 plus 8, 5. Understand? If you have doubt, VB equal to this plus this, that is minus 3 plus 8. KVL अप्लाई करके भी कर सकते हैं यार, आपको डाउट है तो ऐसा ले लो, दिस लूप में एंड फाइंड VB। कुछ भी कंफ्यूजन नहीं होना चाहिए, राइट। सो अभी VA माइनस VB कितना, माइनस 2.4 माइनस 5 माइनस 7.4, दैट्स ऑल, हो गया क्वेश्चन। कोई भी मेथड पे कोई भी ग्राउंड ले लो, डिफरेंस विल नॉट चेंज। घर पे ट्राई करो यही पे ग्राउंड लेके, ओके, यू विल गेट द सेम आंसर अनडाउटेडली। ओके, चलो लेट्स गो फॉर द नेक्स्ट क्वेश्चन। दिस इज ए प्रीवियस गेट क्वेश्चन यार, आप लोग थोड़ा सा ट्राई करो। व्हाट इज योर आंसर? वो बहुत जल्दी दे रहा है यार आंसर, मैं इतना जल्दी नहीं दे सकते। ओके, सो मैं तो 1 मिनट टाइम दिया, लेट्स वेट फॉर अदर्स ऑल्सो टू कॉमेंट so that everybody able to answer. ऑलमोस्ट स्माइली दे रहा है आंसर ऑप्शन ये सभी लोग तो ये दे रहे हैं ओके लेट मी गिव यू द आंसर ओके फाइन firstly what is VCD VA minus VB this is given as 6 this current will be 3 then don't analyze much in this question इसमें ज्यादा एनालिसिस मत करो ये 3 एम्पियर है तो whatever may be the current here this 3 will join here and return here 3 will divide different parts all those things but still come back will be 3 and this is how much this is how much 2 3 and 2 will join and give me 5 5 into 1 5 volts so here if you take this as VC this as VD loop equation karo KVL VC plus 5 minus VD equal to 0 आपका VC minus VD कितना minus हो गया ओके वेरी गुड यार सूर्या वर्षित विक्रम and Divya, Ravi, everybody gave right answer. Okay, chalo let's move for the next question. Right, this is also one of the ESC का examination का question है भाई. Try this question यार. Timer चाहिए. आओ. टाइमर जी शुरू हुआ. वर्षित तो दिया अभी. Last time up. Okay, let's see in the network shown in the figure, the value of Vx would be how much? Okay, listen carefully. Okay, so to find the Vx, let me assume this is my ground. This question I have selected because of the reason it will help you to understand the concept of ground properly. इसलिए मैं तो ये क्वेश्चन सेलेक्ट किया. सो इस वाला नोड को Vx ले लो भाई, बिकॉज ये मेरा ग्राउंड है तो ये Vx होता है. आसान. ये पॉजिटिव ये नेगेटिव ये नोड वोल्टेज कितना होता है भाई -4. ठीक है. सो लेट मी राइट द नोड एनालिसिस भाई. थोड़ा सा मूव कर सकते हैं. Nodal analysis at Vx. Okay, so Vx by 1, Vx minus 6 by 1 plus 2Vx Vx by 1, Vx minus 6 by 1 plus this current, how much? 2Vx. If you know the current, don't worry about the other voltages and all those things. हमको KCL क्या बोल रहा है? Sum of the currents leaving the node is 0. So we should write just simply currents plus Vx minus of minus plus 4 by 2 equal to 0. Take the LCM. 2Vx, 2Vx, 4Vx, right? So here 9Vx equal to 8. आपका Vx कितना होता है? 8 by 9. बस. How many of you have given the right answer? B. Cosmos दिया, Soras दिया, Varshit has given first. Okay. Wait. Now I want to solve this question. मैं इस क्वेश्चन को सॉल्व करना चाहिए दूसरा मेथड पे how sir, without taking ground here, if I take ground here, is this okay to find the Vx sir? Yes, no problem, because Vx is the voltage across the element, not the node voltage. This element voltage can remain the same because the current remains the same irrespective of the ground you take. So let me solve the same question by taking the ground at a different position, guys. So let me show you that. ओके, दिस इज द क्वेश्चन, राइट? सो इसमें आप ध्यान से सुनो भाई, मैं तो ग्राउंड यहीं पे ले रहा हूं. ये ग्राउंड ले लो, then this will be 4 volts. And what is this node voltage? This is 4, this is Vx. So don't take new variable, simply take Vx plus 4. Now solve the question. आपको same answer मिलेगा undoubtedly. Let me prove that. ठीक है? So here let me write the equations by nodal analysis. Okay, what is this current? Vx plus 4 minus 4 by 1, Vx by 1 plus what is this? Vx plus 4 minus 6 minus 4 by 1. Vx plus 4 minus 6 minus 4 by 1 plus 2Vx plus Vx plus 4 minus 0 by 2. Right. So take the LCM. 2Vx, then 4 cancels, minus 12 plus 4Vx plus Vx plus 4 equal to 0. 9Vx equal to 8. आपका Vx same answer. Okay, so you should grab the concept here. जैसा प्रॉब्लम सभी लोग करते भाई ब्लाइंडली, बट आप लोग इतना नेटवर्क्स में एक्सपेरिमेंटाइजेशन करना चाहिए. ऐसा कर सकते क्या, ऐसा क्यों नहीं कर सकते? व्हाट इज द मिस्टेक इफ आई डू लाइक दिस, व्हाई आई एम नॉट गेटिंग द आंसर, विल आई गेट द आंसर इफ आई डू बाय दिस पर्टिकुलर मेथड? ऐसा कुछ सोच के करना चाहिए हमेशा. ठीक है, चलो लिसन. So if I take the ground there I am getting the same answer undoubtedly, because with respect to the ground the current will never change, node voltage will change, voltage difference will never change. इसके लिए सारे examples will help you here. Okay, Here I take the ground differently, here I take differently, and I got the same answers. Right? Very good. So shall we move? Can we move further? Good. Chalo bhai. Let's go for the next question. See, actually, there are some concepts. Maybe I'll take one more session on Monday for equivalent circuits. इसमें series connection, parallel connection, and इसमें भी कुछ basic questions. We will be doing that in one session. Maybe in the next week, not Monday or some other day. I'll plan a session and I'll update. Today we will wind up. अभी तो नहीं, थोड़ा सा टाइम के बाद 10-15 मिनट क्लास लेता हूँ और only we will confine today with the questions of node and mesh analysis only. Okay, chalo. So that's why there are some questions which I can solve easily by using my concepts of source transformation, equivalent circuits, etc. Because I haven't discussed in these 2 days, I'm not using them. Okay, chalo. Let's do a few more questions available for us. Okay, right. Let's try this question here. ये तो गेट का क्वेश्चन है भाई. कल तो संडे भाई, छुट्टी चाहिए. ओके, लास्ट 1 वीक एवरी डेज मैं तो सुबह शाम 3-4 क्लासेस ले रहा हूँ. ओके, संडे जनरल है. I'll refresh. I don't in general take any class unless until it is required, some batch start, something else. I mean, कुछ YouTube में start करना ऐसा कुछ initiative है तो maybe I'll sacrifice and come. Otherwise, I don't take. Time up. Only one right answer. Kaushik दिया option B. Let's see. See here, examiner, firstly, what is this current? कहाँ जा रहे हैं? What is this current? 5/2. 2.5. ठीक है. So 2.5 volts बोलते. ये तो I. Okay. And this is I. What is I? You can say voltage division principle generally we need to apply, but मैं तो explain नहीं किया इसलिए मैं तो apply नहीं कर रहा हूँ. 4 VAB by 4 I accepted. This voltage by this total resistance will give you this current. So VAB क्या होता है sir? I. So But because this is current I na, I into 1 is the drop I. So what is VAB? VA minus VB. VA equal to 2.5. VB equal to minus I. VAB equal to VA minus VB. But what is V? What is I? It is also VAB. So VAB equal to 2.5 minus VAB. So 2 times VAB equal to 2.5. आपका VAB कितना होता है सर? 1.25. That's your I. Got it? So अभी तक जो डिस्कस किया every single problem you can solve just and just by using KCL, KVL, node, mesh analysis. इसके अलावा आपको कुछ नहीं चाहिए. Okay? So let's move further. Very good, very good, very good. चल. Try this question. A network with a dependent sources. You need to find this V naught. Monday, Satya, Surya, I will be taking equivalent circuits. If not Monday, next week I'll announce equivalent circuits, series connection, parallel connection, और इस केस में voltage division, current division के बारे में we'll be discussing the problems based on that. You can see the sample problems here. I'm sorry. These kind of questions, all these things we'll solve. इस क्वेश्चन को कोई आंसर नहीं दिया क्या? सभी लोग सो रहे हैं क्या? सैटरडे नाइट एंजॉय कर रहे हैं? ओके, थोड़ा सा देर वेट करो, आई विल आल्सो लीव यू. Okay, here I'll be solving the question. This current will be V naught by 3 because the voltage is V naught, resistance is 3, V naught by 3. And okay, this will be V naught by 3. And this will be how much? V naught by 3 will give you 3V naught, sorry, 4V naught by 3. Apply KVL. We need to find the current. No problem, we'll find it. But first find V naught. KVL चाचा बताओ यार 24 नेगेटिव से पॉजिटिव माइनस वी नॉट बाई 3 नेगेटिव से पॉजिटिव ना प्लस 2V naught पॉजिटिव टू नेगेटिव माइनस वी नॉट पॉजिटिव टू नेगेटिव माइनस 4V naught बाई 3 इक्वल टू 0. So 24 equal to V naught plus 5V naught by 3. Minus V naught. Okay. It will be 2V naught by 3. Right. So what is V naught by 3? 24 by 2, 12. That is your current time. एक ही single step में you will be able to solve it. Very good. 12, 12, 12. Sindhu Kumar, Sachin, Surya, right answers. Yeah, Laplace तो important है, not only for AC. AC में maximum we do by phasor analysis. Laplace is important for your transients mostly. Not only transient, यार control systems पूरा Laplace ही है. Okay, many cases we apply that. Next question, guys. Right, this is the question for you. So give a try. So please try this question. So if the differential equation for the circuit shown in the given figure V dot equal to 4 Vt minus 4, then set off the values of E, R, C respectively. What can be your E, what can be your R, what can be your C is the question. Okay, so anybody right answer? Not yet received any comment? Any right answer? Waiting for your answer, guys. So आप लोग चार्ट पे देख सकते ना, एक पिन चार्ट में that link if you press you can follow me on Unacademy. You can be in touch with me on my special classes and all. Vikram दिया three क्या भाई 1 2 3 4 में what can be your answers? Only 3 is your answer. That option is not available. Okay, I will be solving it, guys. Listen here. So I want to say, or I want to help, I want to suggest you one thing, my dear students. Networks is the subject where you can score the best. आपको 100% भी स्कोर कर सकती है इस वाला सब्जेक्ट में. प्रॉपर कंसंट्रेशन, प्रॉपर एक्यूरेसी मेंटेन किया तो with minimal effect you will be effort you will be able to score up to 100%. So whether you are studying from any platform, having whether you are coming for the plus or YouTube, whatever, full-fledged way, may please learn it. Okay, I already told you full course playlist is available on this YouTube, which is complete free for you. Just go through it. Okay, just go through it. You will be able to learn. For plus subscribers, from Monday onwards, I'm starting another practice course. If plus subscribers are in this class, Monday 7 a.m. से शुरू कर रहा हूँ. आप लोग उस पे आ सकते हैं. Travel और केवल problem solve करेगा. So okay, fine. Let's go for this. Here, uh, so current in the capacitor, C dV by dt, right? What is this current? I. It is equal to C dV by dt. Why, sir? Because series में current same ना. If this is C dV by dt, this is also C dV by dt. Okay. So VR. What is your E? VR plus V. What is your fine? What is VR? VR is equal to I. I is R into current C dU by dt plus V equal to E is the differential equation of this network, right? So I can write this as RC into dV by dt equal to uh, V minus E. Okay, understand what I am saying? Or E minus V. Okay, RC into dU by dt equal to E minus V. Okay, so here what is dV by dt? E by RC. Okay, so this is your V dot as per options minus V by RC plus E by RC. So substitute this equation, compare with this one minus 4V plus 4. Okay, so here what is 1 by RC? RC equal to 1 by 4. Compulsory RC must be equal to 1 by 4. And your E by RC equal to what is that? 4. Okay, and you know RC equal to 1 by 4. So 4E equal to 4. What is your E compulsory? 1. So from this equation, I can conclude E must be 1, RC must be 1 by 4, that is 0.25 is the required condition for this equation to be satisfied. So first thing, what are the values of E? E must be 1, 2 and 3 are wrongs. RC must be equal to, that is R into C must give me kya? 0.25. 1 into 0.25 or 0.25 into 1, both will give you the same answer. So 1 and 4 is the right answer. Understand? Option D. Very good. Who is that? Sindhu Kumar. Very good. Good. Shall we move further? Right. Next question, most probably last question for today's class. Last or last not one. So please give a try. You need to find I1, I2, I3, the mesh currents. Last 10 seconds. आज आपका response थोड़ा सा slow हुआ क्यों? I mean, relatively less number of people are giving answers. Tell me. No answer yet. Okay, chalo, let's move. In the given circuit, the mesh currents I1, I2 and I3 will be. Okay. थोड़ा सा loop analysis करना चाहिए. Here between I1 and I3 there is a current source. As I told you earlier, we should combine both of them and write the single equation, right? Current enters from positive, leaves from negative. Current enters from positive, leaves from negative. So at I1 and I3, minus 6I1 minus I3 minus I3 minus 2I1 equal to 0. 8I1 plus 2I3 equal to 0. 4I1 plus I3 equal to 0. Equation 1. Here, this is I3, this is I1. You should apply KCL. Okay. 2 plus I1 equal to I3. I1 last question, last equation. This 5 minus, अरे यार मैं गलत किया, क्या हुआ मेरा? सॉरी यार, बेसिक इक्वेशंस भी गलत किया तो क्या? आप लोग किया तो ठीक है, मैं भी कर रहा हूँ. सो मे बी सैटरडे नाइट का इफेक्ट. आई एम वेरी सॉरी. I am sorry. So here you start positive to negative minus 2I1. Here two currents are flowing now. This is I2, this is I1. So positive to negative minus I1 minus I2 into 6. Here minus two currents are flowing. I3 minus I2 into 1 minus I2 into 1 equal to 0. This is the one equation. By KCL here, okay, this is I1, this is I3. So 2 plus I1 minus I3 equal to 0. Second equation, first equation, okay. Last equation here, first mesh में negative to positive 5, positive to negative minus I1 minus I2 minus I3 into 1, positive to negative minus 6 into I2 minus I1 equal to 0. Solve 1, 2, 3. Maybe now मैं solve कर रहा हूँ I1, I2, I3. This is how you need to do with the super mesh analysis. Okay. Whatever may be the option you can take. Okay. So options तो छोड़ दो भाई. मे बी मैं कैलकुलेशन तो नहीं कर रहा हूँ, ये तो बहुत बोरिंग पार्ट है, बट द प्रोसेस तो यू कैन अंडरस्टैंड. A circuit consists of dependent independent source is shown in the figure. If the voltage at the node 1 is -1 and voltage at the node 2 will be how much? Lucifer, मेरा पास भी आंसर नहीं, ठीक है. I mean, unless I solve, I don't know this for this particular case. Okay. So for the circuit consisting of dependent and independent source shown in the figure, if the voltage at the node 1 is -1, a node voltage to -1 है भाई. What is the voltage at the node 2? Okay, right. So please try this question. I'll wait. I'll wait. Please try this question. So time up. क्या हुआ यार, कोई भी आंसर नहीं दे रहा है. लास्ट फ्यू क्वेश्चंस में इंटरेस्ट गया क्या? Listen, if this is -1 means this polarity should be like this. So in this direction you are getting 1 ampere. Then this current will be 2 amperes. Okay. So I2 is 2, this will be 4 amperes. So this is 2, this will be 4, then this will be 6 amperes. Okay. So listen here. What is the examiner question? 6 into 3, this 6 into 1 by 3 will be 2. So what is the node voltage you will be getting is 2. Okay, because he has given this node voltage, I take this voltage here, I find the current positive to negative direction pe. One is entering, one is entering, two will be leaving. I2 is 2, then 2 I2 will be 4. Okay, then 4 is coming, 2 is coming, 6 will be leaving. 6 into 1 by 3, what is my answer is 2 volts. Okay, simple सी बात. ज़्यादा टाइम नहीं चाहिए इस क्वेश्चन को. Okay, fine, no issue. Right, I think we are done for today. Done for the day. Okay, we did wonderful number of questions and good different models of questions we have done. I hope you enjoyed the session today, right? So let me give you a few updates regarding our special class initiatives. Special class में आपको if you want to watch my special classes, one thing you can do is just follow the link में description पे you have the link in the I mean in the what we call sorry chart में it is pinned one link. Please press that and follow me on Unacademy. You can watch all my free special classes. Live special classes में you have the advantage. You can talk to the educator, you can interact with the educator, and you can solve your doubts live as easily as possible. And right, tomorrow is a big day, guys. An Academy Ultra Combat is going to happen. That is at 11 a.m. So enroll now, guys. Video description पे गए अंदर it is available. So please don't miss it. इस exam आप लिखना चाहिए. So check yourself whether how you are performing and where you are doing the mistakes. All these things will be happy. Will be there. Thank you, Sachin. Thank you, Vikram. Thank you, Pranit. Very much. Thank you very much. Okay. So you can use the code Shankartan and enroll to the exam. And congratulations to all our toppers of GATE 2023 and ESC, sorry, GATE 2022 and ESC 2021. From the few toppers you can see on my board. I always wish my students who are watching my lecture to be in this on this screen next year. So these are the new batches started 2 days back on an academy, guys, and three subjects have been started by Ankit sir, BV Reddy sir, and Siddharth Sabharwal sir. Okay, so these are the subjects you can see, and this is an academy light subscription for test series, guys. आपको test series केवल और केवल test series चाहिए तो बहुत बहुत कम प्राइस में आपको मिल रहा है around less than 2000 you will be getting it. You can use the code Shankar10, you will be getting 10% discount here also. Right, this is about our campus placement initiative. Right, thank you very much. Okay, गुड नाइट. फिर मिलेगा नेक्स्ट वीक पे मोस्ट प्रॉब्ली. मैं तो मंडे लेता हूँ इक्वलेंट सर्क्यूट्स का सेशन. ओके, आई विल शेयर दिस नोट्स ऑन द टेलीग्राम चैनल टुडे और टुमारो कंपल्सरी. So don't miss it. I'll be sharing it you so that you can do the practice also. Thank you very much, guys. Love you all. Bye bye.